So anyway, today we're going to take a little bit different direction. We're going to talk about a little bit of basic geometry. We're going to talk about areas. But to do that, we're going to build up from basic geometric concepts. And we're going to start out with the most basic concept in geometry, which is that right there. It looks like a dot. It is called a point. It is simply a location. It has no dimensions. It is just indicating a spot on a plane or in just any location in space. Everything in geometry is built from that concept, though, and from moving that concept, or what we call translating that concept. If we take that point and we move it in a single direction, we create a line segment, or just a segment. It's often just called a line. Truly, a line goes on forever in both directions, but in reality, that's not practical. That line segment has a length. And the length of that line segment is equal to the distance that the point was moved. So in geometry, length and distance are really the same concept. From there, we can take that line segment and we can move it again. What we have to do is we have to move it what's called perpendicular. What perpendicular means is it has to be at a right angle or totally different direction, like east is perpendicular to north or up is perpendicular to west and so on. So you have to move it perpendicular to the original direction that it was moved. So it might be straight down like this. And if you think of it as a stick in the sand, as you pull it, it'll trace out a rectangle. That rectangle, of course, will define an area. And the size of that area depends on the original length of the line segment to begin with, and then the distance that we moved it. And that distance is often referred to as a width. So an area is a length times a distance. Rather than defining it as length times width, I keep it defined as length times distance because that's a more universal definition of area. So let's say I have a rectangle that's formed like this, where we had a 12-inch segment that is moved and pulled 8 inches in distance or 8 inches in width. Now, we should be told that those are right angles before we can conclude that is a rectangle. To calculate any sort of area, we have to have two dimensions that are at right angles, or again, perpendicular to each other. So the area of this is going to be the 12-inch length times that 8-inch distance or width. We multiply the counts. 12 times 8 is 96. We also multiply the names. Inches times inches are inches squared, or square inches. Now that length, let's go back and say we still have a 12-inch length. That length does not necessarily have to move perpendicular. As long as it moves and stays parallel to its original orientation, like that, it doesn't twist at all, we can move it at an angle like that. The key is that the distance it moved is still measured at a perpendicular. So it started up here at that black line and it ended down here. The distance moved is still measured like that. And as long as that distance moved is still 8 inches, the area here is still 12 inches times 8 inches, or 96 square inches. In fact, it doesn't even have to move in a straight line. Let's, again, go back to that being 12 inches. And we might take it and move it like this. As long as it stays parallel to its original orientation and doesn't twist or turn or anything. The area of this is still simply measured by its length, the 12 inches, and the distance between where it started and where it stopped. So if that's 8 inches, again, what do you think the area is? Well, there you go. Still 12 inches times 8 inches, or 96 inches squared. So using that idea of a length times a distance, it not only allows us to find the area of rectangles, but of any shape that is like that, where we have, they're called bases again, where the top and then the opposite side are the same, and it's formed by keeping that side parallel to its original orientation and moving it along. Other shapes that we can run into, of course, are triangles. We might run into something like this. Let's say that this is 12 inches here, and this is 8 inches. To find the area of this triangle, we have to look at it in terms of a rectangle. The area of that rectangle would be, again, 12 inches times 8 inches. The triangle, however, is only half of the rectangle, so we would divide by 2. So it's 12 times 8 divided by 2, or 48 inches squared. Now, it was easy here because this was a right triangle, and it was pretty easy that that right triangle was half of that full rectangle. But even if it's not a right triangle, let's say it looks like this. This is 12 inches. Now, none of the other two sides can be used because they're not perpendicular to the 12. We have to have a dimension perpendicular to the 12. Not only does it have to be perpendicular, though, it has to define the rectangle that this could be cut out of. Well, that would be that rectangle there. So the dimension that would define that rectangle with the 12 would be this dimension here. And if that's 8 inches, the area of that triangle is still 12 times 8 divided by 2, or 48 square inches. Looks familiar so far? Most of you have had this before, right? Well, we can keep going. We could have trapezoids and other shapes. Let's talk about trapezoid. A trapezoid is a fancy word for a relatively simple concept. It's a four-sided figure where there's two sides that are parallel. So that's a trapezoid. And let's say that this is 8 inches on top, and we're going to go 22 inches on bottom. And the distance between those two bases, the two sides that are parallel are called the bases. The distance between those two bases, we're going to go with 10 inches. Well, the triangle, we turned it into a rectangle, and we cut it in half because the triangle was half of that related rectangle. We're going to do something similar here. We're going to go halfway down this sloped side, and we're going to cut this down here at a right angle, square it off. This piece should be able to flip up and exactly fill in that missing spot. We'll do the same over here. Go halfway down, cut it off, flip it up, and there it is. We now have a rectangle. The rectangle still has a height of 10. It's just the length that we don't know. But we know the length is somewhere between the 8 and the 22. Well, it happens to be exactly between the 8 and the 22. The length of that rectangle is the average of those two bases, the 8 and the 12. So in the area would be the average of the bases, gives you the length, times that width or height of 10. So here's where our order of operations comes in from the other day. 8 plus 22 is 30. 30 divided by 2 is 15, times 10 is 150 inches squared. Excuse me. And then we run into shapes that are combinations. They're not simple rectangles or triangles or trapezoids. They're combinations. They might look like this. Let's say that this is 10 inches. We'll go 4 here, 2 and 2, 6 here, and 10 inches there. If I want to find the area of this, there's actually two different ways I could approach it. One way would be to do this. I'm just going to cut it into rectangles. I have a top rectangle up here that is 2 inches by 10 inches, which will make it 20 inches squared, or square inches. I have a second rectangle here. We know it's 6 inches tall. What's the dimension across here? This is something a lot of people struggle with, is finding missing dimensions. We see that it's 10 inches all the way across, right? So subtract 4 would be 6. Subtract another 4 leaves us with 2. So that's 2 inches. That's one of those skills that if you struggle with it, you need to work on it and develop it. Because it is something a lot of people struggle with, the visualizing and finding those missing dimensions like that. So that is 6 inches high, 2 inches wide. So 6 by 2, or 12 square inches. And then the bottom one down here, the third one, that's 10 by 10 for 100 square inches. So we add that up to get 132 square inches. That's one way that that problem could have been solved. The other way is like this, or the other strategy looks like this. We can fill those in and make it one big rectangle. That big rectangle is 10 inches across here. 2 and 6 is 8 plus 10 is 18 inches tall. 10 by 18 is 180 square inches. But now we have these two that need to be subtracted out. 4 by 6 is 24 square inches. That needs to be subtracted. And there's another one that's 24 square inches on the other side. We subtract those out and we end up at 132 square inches. So we end up at the same area either way. It's just a matter of which one you prefer. And a problem like this is probably about the same amount of work either way. I think the second way is a little easier because you didn't have to find any missing dimensions, except for adding up, the total height is all. And on many problems, it's going to be like that. It'll be, sometimes it'll be just as easy to add them up as it is to find a big one and subtract out the missing pieces. But you might have one like this one. Let's do this. Find that area. This one, trying to make a big rectangle and subtracting out the pieces wouldn't work real well. It's not so easy to find the dimensions that way. So this one is one that actually would be easiest, just to cut it into pieces and find the rectangles. First thing we need to find is we're going to need to find this dimension here, which is 4. Good. It's 10 across here. It's 6 here. That remaining piece has to be 4 to add up to the 10. So that is 4. So that means this is 4 over here as well. So we have this first triangle that is, or rectangle, so it's 2 by 4 plus 2 is 6. So 2 by 6 is 12. The second one here, which is 4 by 6, or 24. And then this is 4 by 10, or 40, which adds up to 76. Since I didn't put inches or feet or anything on there, we're going to call that units squared, is what that is. But we might also run into ones like this. Looking at one like that, cutting it into rectangles is going to be tough because these edges don't line up here. It's really, you cut it into a lot of small rectangles to cut it up. But this one, it would be relatively easy to make it a big rectangle and subtract out the 2 missing pieces. So this is 2 plus 4 is 6, plus 12 is 18 by 10 plus 2 is 12. So 18 by 12 is 216 units squared. And we're going to subtract out. This is going to be 4 by 8, which will be 32. This one is 2 by 6. 2 and 4, 12 is 18. 12 minus 18, or 18 minus 12 is 6. So 2 by 6 is going to be 12. So we're going to subtract 12. Let's see, it's 172 square inches or square feet or whatever it is. Not so bad? Well, the next step is to start talking about volume. volume is just taking this all to the next level. Now we created an area by taking this length and then pulling it to make the area. To create a volume, we take that area and we move it in a third direction, perpendicular to each of the first two, and it creates a box. That area that we start with is called our base. The volume is equal to the area of that base times whatever distance we move it, and that distance is called the height. So if we're looking at a box, like that. The base, we're going to call the bottom here the base. Let's say that this is 8 inches, 6 inches, and 10 inches. The area of our base is just a rectangle that's 8 inches by 6 inches, or 48 square inches. So then the volume is that area of the base, 48 square inches, times the height of 10 inches, or 480 inches cubed. Now you might be thinking, you were taught volume is length times width times height, right? And it is. The length times the width is just the area of the base. The reason I define it this way is because it allows us to take shapes that are a little bit irregular and still find their volume. For example, take something that looks like that. Let's label this as 12 inches across here. We'll go 3 inches, 4 inches, 10 inches, and we'll say that this is 5 inches thick. What we need to do is we need to figure out what shape this is based off of. Well, it's pretty obvious that this T shape here is what it's based off of, because that was the area that we lifted up or whatever, moved up and down to create that object. So we need to find the area of that T shape, and we'll multiply by that height or thickness of 5 inches. So to find that area, we're just going to cut it across here. We have a 12 by 3 rectangle, which is 36 square inches. Then here we have a 10 by 5 rectangle, so that's 50 square inches. So the area of that T-shape, or the area of that base, is 86 inches squared. So then the volume is that area, 86 inches, times the height or the thickness here, that's 5 inches, or 430 inches squared. It is 10 by 4, isn't it? Not 10 by 5. Thank you. That would be 40, so this would be 76, wouldn't it? Thank you very much. That is 10 by 4 down here, not 5. So it would be 10 by 4 would be 40, so our total area of that base is 76. Thank you. So 76 times 5 would be 380 inches cubed, because you have square inches of area times inches gives you cubic inches. Now let's do at least one more example for you. What's that?
Anytime we had a drafting project, we always walked in and out of drafting board.
A shape like this?
Yeah.
Oh yeah? Little nap did you some good? Okay, let's look at something like this. Now here again, the key is to figure out what the base is. The base is not the bottom or the top on this one. Normally we've used the top or the bottom as our base. On this one, however, it's this piece on the side. that we need to find the area of. And that piece then is pulled through this distance to create this object. So we're going to cut this into rectangles. We've got this first one, which is 14 by 4, or 56 inches squared. This second one here is 6 inches here by 6 inches here. 14 minus 8 gave us 6. So 6 by 6 would be 36 inches squared. Then we have this one, which is 10 by, well, 6 plus 2 would be 8 inches. So 10 by 8 is 80 inches squared, which is what, 172 inches squared. That is the area of the base. So then our volume is going to be simply that area, 172 square inches, times this thickness, which was 6 inches. A 1,032 inches cubed. What do you think? Good stuff? Well, in your book, page 17 through 19, it'll be 1 through 39, the odds. Take you through areas and volumes.